Welcome to the deep dive. Today, we are looking directly at you, the learner, and we're tackling a massive pain point.
Oh, it really is a huge one.
Right, because, I mean, think about it. You could easily spend 3 years in a lab or out in the harsh elements of a field study, or, I don't know, completely isolated, just hunched over a computer modeling massive data sets.
Yeah, just completely drained.
Exactly. You put your blood, sweat, and tears into getting that perfect scientific result. But if your writing is terrible, if you just can't communicate that jewel of a finding, it goes straight to the graveyard of desk rejections.
Or, and honestly, this is sometimes even more frustrating.
Oh, yeah.
Yeah, it actually gets published,
Mm.
but in a journal that literally nobody reads.
Mm.
And it just, slowly fades into total obscurity.
Ugh, that is tragic. So our mission today for this deep dive is to explore the surprisingly complex art of turning raw scientific data into a highly cited, successfully published paper.
Which is an art form, really.
It totally is. And we are pulling together the absolute most current 2024 to 2026 guidelines from publishing heavyweights. We're talking Elsevier, Nature, PLOS, UNESCO, and the Vancouver Group.
Big ones.
Yeah, the real heavy hitters. And I like to think about it this way. Doing the actual science, right, that is basically like sourcing the rarest ingredients and cooking a Michelin star meal.
I love that analogy.
Thanks. But like writing the paper, that is the plating and the menu description. I mean, if the plating looks completely unappetizing, nobody's going to want to taste the food, no matter how objectively delicious it is.
That analogy holds up perfectly under scrutiny. It really does.
Yeah.
And before we even get into the mechanics of plating this meal, we kind of have to address a deeply ingrained, almost romanticized myth in academia.
Okay, lay it on me.
It's this idea of the innate writer.
Oh, right.
Yeah, there's this pervasive assumption that if someone is, say, a genius at quantum physics or molecular biology, they should just automatically be a master wordsmith.
Right, like if you can solve complex differential equations in your sleep, then, stringing together a coherent paragraph should be child's play.
Exactly.
But I imagine that is absolutely not the case.
It's a massive misconception. And frankly, it does a terrible disservice to researchers. Writing is not some magical talent bestowed upon you at birth.
Right.
It is a highly trainable mechanical skill.
Yeah.
But because the scientific community focuses so heavily on the technical methodology during a researcher's education.
Like the math, the biology, chemistry.
Right, all of that. Because of that focus, the actual communication of those findings is often treated as a total afterthought. We have to completely dismantle this myth. You learn to write the exact same way you learn to operate an electron microscope.
Which is what, just practice?
Instruction, repetition, and refinement. That's it.
Okay, so if we are treating writing as a mechanical skill to be learned, let's start at the absolute micro level.
Okay, let's do it.
The actual words on the page. Because when I look across all these updated guidelines from Elsevier and Nature, rule number 1 of scientific writing is clarity and precision.
Always.
But they really emphasize that writing clearly doesn't mean dumbing it down.
No, not at all.
So what does that distinction actually look like in practice?
Well, it means eliminating noise. You want to remove any cognitive friction between your data and the reader's brain. For example, the current consensus suggests a target sentence length of about 15 to 20 words on average.
Wow, that's pretty short.
It is. And there is a very specific neurological reason for that. Human working memory can only hold so many chunks of information at once.
Okay.
If your sentence stretches to 40 or 50 words, by the time the reader gets to the period, their brain has literally disconnected the subject from the verb.
Oh, man. Yeah, I've read papers like that.
Right. They have to go back and reread it.
That makes total sense. You're just exhausting the reader's working memory before they even get to the point. And I also noticed the guidelines wage an absolute war on the passive voice.
Oh, an absolute war, yes. Because for decades, scientific papers relied on these eternal, dry, passive constructions. You know the ones.
Like, it was demonstrated by our team that...
Yes, or the samples were centrifuged at whatever RPM. When you use the passive voice, the reader's brain has to hold on to the action and wait in suspense to find out who or what actually did it.
Like a really boring mystery novel.
Exactly. Active voice delivers the who and the what immediately. You just say, we demonstrated that, or we centrifuged the samples. It simply saves cognitive energy.
But wait, don't scientists actively love complex jargon?
Well,
I mean, I feel like there's this underlying pressure in academia to sound smart. Sometimes I read dense academic papers and it literally feels like the author is a squid spraying ink to hide from
a
predators.
squid spraying ink. That's a great image.
Like, if they use enough multisyllabic words and convoluted sentences, no one can actually figure out their methodology enough to critique it.
The squid ink phenomenon is very real. It's often driven by a sort of academic imposter syndrome. But, what's fascinating here is that the data proves this strategy completely backfires.
Really, it doesn't make them look smarter.
No, true expertise is making the complex accessible. Evidence from recent publishing metrics clearly shows that papers using direct, straightforward language receive significantly higher citation rates.
Wow, higher citations just for being clear.
Exactly. When you hide behind a cloud of squid ink, other researchers can't easily parse your findings. And if they can't understand your work quickly, they cannot build upon it.
Right.
And if they can't build upon it, they won't cite it. Your paper just dies in a silo.
Okay, so we've stripped the squid ink out of our sentences. We have crisp 15-word active voice statements.
Perfect.
But clear sentences are kind of useless if they are arranged in a chaotic order, right?
Uh-huh.
How do we actually organize them so the reader doesn't get lost? Because honestly, a chronological list of lab results sounds incredibly boring.
It is incredibly boring, which is why the guidelines insist on a skeleton that relies on classic storytelling.
Wait, storytelling in a science paper?
Yes, you need a scientific narrative arc. It follows a very specific progression. You start with a problem, like the big picture issue in the world or the field.
Okay.
Then you identify the gap in current knowledge. What don't we know yet? That gap logically leads to your specific question. Then you present your evidence, and finally, the resolution.
Oh, so it really is the exact same structure as a mystery novel.
Pretty much.
And before you even start drafting that mystery novel, the sources insist on defining the main point of the paper in a single declarative sentence,
Usual step.
which feeds directly into what they are calling the 2025 Golden Rule. And I have to say, this blew my mind.
Let's hear it.
If you cannot explain your research in exactly one tweet and one key figure, you need to completely rethink your concept.
The tweet and figure rule. It forces ruthless prioritization.
It really does.
Let's say you've spent 3 years studying a specific enzyme's effect on cellular decay. Your brain is swimming in 1,000 tiny, fascinating details.
Right, because you lived it.
Exactly. But if you try to put all 1,000 details on equal footing in your paper, the reader is overwhelmed.
Right.
If you can't distill it down to enzyme X slows cellular decay in mice by 30% through Y pathway, alongside one clear graph proving it,
Yeah.
then you don't actually know what your paper's about yet.
That is so wild.
Yeah.
And, if you're listening to this, apply this rule to your own daily life.
Absolutely.
Whether you are prepping to pitch an entirely new marketing strategy in a corporate board meeting, or, I don't know, you're just trying to explain your complicated new sourdough baking hobby to a friend.
We all have that friend.
Right. If you can't pass that tweet test, you've already lost your audience's attention. If you don't know your single most important takeaway, the journal editor certainly isn't going to spend their afternoon figuring it out for you.
Precisely. They will just reject it and move to the next manuscript in the pile.
Okay, so we have our tweet, our declarative sentence, and our narrative arc. But you can't just submit a literal storybook to nature.
No, you definitely cannot.
Journals have incredibly rigid traditional structures. So how do we map this flowing narrative onto that rigid architecture?
You use the globally recognized IMRD format.
IMRD, okay.
That stands for Introduction, Methods, Results, and Discussion. It became the standard not to stifle creativity, but to create a predictable architecture for exhausted peer reviewers.
Ah, they need to know where things are.
Exactly. They need to know exactly where to look for specific information.
Yeah.
But you have to optimize how you use it. Let's look at the introduction. The guidelines suggest shaping it like an inverted cone.
An inverted cone, so broad at the top, narrow at the bottom.
Exactly. You start broad with the overarching global problem. Climate change affecting crop yields, for example.
Okay, very broad.
Then you narrow down the cone to the specific gap in the literature. Like, we don't know how this specific wheat variant reacts to early frost. And at the very tip of the cone, you state your precise objective and hypothesis.
Got it. Then we hit the methods section. Now, I have to be honest here.
Oh.
Whenever I'm reading a scientific paper, I usually skip the methods section entirely.
Most people do.
It's usually just a massive wall of text about centrifuge speeds and software versions. Is it really that important to the narrative?
Well, that is exactly why we are currently facing a massive reproducibility crisis in science.
Oh, wow, really?
Yes. The methods section isn't meant to be poetic. It is a highly detailed recipe meant purely for replication. If you skip a step in a recipe, the cake falls flat.
Sure.
In science, if you don't include exact software versions, specific statistical parameters, and environmental conditions, no one else in the world can duplicate your exact experiment to verify your claims.
Wow. Okay, so it's less about the story in that section and entirely about providing the blueprints.
Yes. And that blueprint flows right into the results section, which is strictly the facts.
Just the facts.
Zero interpretation.
Yeah.
You let the tables and the figures do the talking.
Yeah.
You do not explain why something happened in the results. You just state what happened. The interpretation is entirely fenced off and reserved for the discussion section.
So the discussion is where you finally bring the narrative back together.
Correct. That is where you interpret the data, compare it with other literature, openly state your limitations, which is crucial for credibility, by the way, and suggest future paths for research.
Okay. But, as important as that entire IMRD body is, the guidelines make it very clear that the title and the abstract are arguably doing the heaviest lifting of the entire paper.
Oh, absolutely.
The rules for a title right now are absolutely ruthless. We're talking 10 to 15 words, max.
It's tight.
Yeah, it has to be informative, attractive, and packed with SEO keywords so people can actually find it in massive digital databases.
Right, because if a search algorithm can't find your paper, it practically doesn't exist.
Exactly. And then you have the abstract, usually 200 to 300 words. And it absolutely must have that take-home message we talked about in the very first sentence. Just thinking about the mechanics of it, the abstract functions exactly like a movie trailer.
Ooh, let's pull that analogy apart because it's highly accurate. What makes a good movie trailer?
Well, it gives you the genre, establishes the main conflict, introduces the stakes, and gives you a hint of the climax without spoiling every single detail of the third act. It convinces you to buy the ticket.
Exactly. Your abstract has to give the journal editor the problem, the gap, your methodology, and your ultimate takeaway in roughly 250 words.
That's a lot to pack in.
It is. But even if the movie itself, the intricate methods and groundbreaking results you spent years on, is an absolute Oscar-winning masterpiece, if the trailer is boring or confusing or hides the premise of the film, the editor isn't buying a ticket.
They don't have the time to guess if the movie gets good in the second hour.
Nope.
So if the abstract is the movie trailer, then the data visualization, the figures, the charts, and the references, those are the special effects and the end credits.
Nice.
How do we ensure those hold up? Because looking at these guidelines, they are incredibly strict about visual evidence.
This raises an important question, right? Because data visualization isn't about aesthetics or making your paper look pretty.
Right.
It is a matter of scientific integrity. Figures must be crystal clear with self-sufficient legends. That means a reviewer should be able to look at your graph, read the little paragraph below it, and understand exactly what is happening without having to hunt through the main text for context.
I also noticed a huge emphasis on colorblind accessibility.
Yes.
Making your charts colorblind friendly isn't just a nice bonus anymore. It's a hard requirement. Which makes sense. If your peer reviewer happens to be colorblind and they can't distinguish the red line from the green line on your critical graph,
They are just going to reject the paper because they literally cannot evaluate your evidence.
wow.
Yeah.
Yeah, that makes total sense.
Exactly. And alongside visual transparency, there is a mandate for absolute statistical transparency. You can't just throw a trend line on a chart and call it a day.
No trend lines.
Well, statistics are the load-bearing pillars of your scientific claims. You must always include your p-values, your confidence intervals, and your effect sizes.
Gotcha.
These numbers tell the reviewer how likely it is that your results were just a fluke. If a figure is misleading or lacks these statistical pillars, the entire foundation of the paper crumbles.
Okay, so we also need to talk about the end credits, the references. The rule here seems to be, don't just cite to cite. You shouldn't be padding your bibliography with 50 older papers just to look well-read.
No, definitely not. You need to ensure your sources are recent, relevant, and high impact. And the guidelines highly recommend, bordering on demanding, the use of reference management tools. Software like Zotero, EndNote, or Mendeley.
Basically a robotic librarian that lives in your computer.
That's exactly what it is. A robotic librarian that instantly formats your bibliography and ensures you never mismatch a citation in the text with the wrong paper in the references.
Because doing that manually is a nightmare.
The sheer volume of published literature today is infinite. If you try to manage your citations manually, you will make a mistake. And an outdated or incorrect citation damages your credibility with the reviewers immediately. It tells them you aren't paying attention to the details.
Okay, so let's put ourselves in the shoes of the learner right now. You've done all of this. You've stripped out the squid ink. You've used the active voice.
Sounds good so far.
You have your 15-word SEO title, your punchy movie trailer abstract, your colorblind friendly figures, and your robotic librarian has perfectly managed your citations. You might think you're ready to hit submit, go to sleep, and pop the champagne tomorrow.
Oh, if only it were that easy.
Right, because according to the reality of the industry, you're actually just entering the hardest phase, the editing gauntlet and facing the journal reviewers.
It's a gauntlet, truly. The self-editing process requires immense discipline. The consensus recommendation across all these institutions is that once you finish the draft, you must let it rest for 48 to 72 hours before reviewing it. Do not look at it.
Why the strict time limit? What actually happens in those 2 days?
You need to break your brain's habituation to the text. When you've been staring at the same paragraphs for weeks, your brain stops actually reading the words on the page and starts reading what it thinks it wrote.
Oh, wow. I've totally experienced that.
Right. When you come back after 72 hours, and crucially when you read it out loud, you will instantly catch clunky sentences and massive logical leaps that your eyes previously just skimmed over.
Man. So if you're listening to this and you've got a draft sitting on your hard drive right now, applying that 72-hour resting period and reading it out loud is exactly what you need to do tonight.
Highly recommend it.
And while you're editing, there's this fascinating structural trick mentioned in the guidelines, the first and last rule.
Ah, yes. This is deeply rooted in psychology, specifically the primacy and recency effects.
Okay, break that down for us.
Human attention peaks at the beginning of a sequence and at the end. The middle is where attention sags.
So applied to writing, that means you need to open and close every single paragraph with your absolute strongest ideas. The middle of the paragraph is where you hide the necessary but maybe slightly drier supporting details and citations.
Exactly. The real estate at the beginning and end of the paragraph is prime territory. It is a brilliant way to ensure your narrative arc never sags. But, even with a perfectly edited paper, one that utilizes all these cognitive tricks, we have to talk about emotional resilience.
Because the rejection rates are terrifying.
They are.
I mean, the numbers here say Nature rejects about 90% of the submissions they receive. 90%.
It's steep.
How does anyone survive in a profession with those odds? It sounds like being an actor going to a brutal Broadway audition every single day, giving the performance of your life, and constantly being told next. Why are the reviewers so harsh?
Well, to understand the rejection, you have to understand the mechanism of peer review. Reviewers are usually other working scientists. They are unpaid for the specific task, they are overworked, and they are staring at a massive slush pile of submissions.
Unpaid and overworked. A dangerous combo.
Exactly. They aren't reading your paper hoping to fall in love with it. They're reading it actively, looking for a reason to cull it from the pile. A missing confidence interval, a convoluted abstract, a mismatched citation. These give them an easy excuse to hit reject.
So the advice to, not take it personally isn't just a platitude. It's the literal reality of the system. They aren't rejecting you. They are just managing their own overwhelming workload.
Precisely, which is why the guidelines explicitly address emotional resilience as a core scientific skill now.
That makes a lot of sense.
The solutions offered are highly practical. First, target realistic journals. Don't just throw everything at Nature or Science hoping for a lottery win. Find a specialized journal where your paper actually fills a needed gap. And crucially, you have to learn to celebrate the submission of a paper, not just the acceptance.
I love that shift in perspective. The act of finishing and submitting that manuscript, of pushing the boulder up the hill, is a massive milestone in itself.
It is. Now, speaking of modern challenges and preserving our sanity, we cannot have a deep dive on writing in 2026 without addressing the elephant in the laboratory.
Yes. Artificial intelligence.
AI and the chronic lack of time every researcher faces.
It's everywhere. And the ethical guidelines for 2026 are very clear on where the boundaries are. AI is a fantastic co-pilot, but it must never be the pilot.
Think of AI like a cognitive exoskeleton.
Oh, cool.
Right. It can help you carry the heavy mechanical load of writing. It is an excellent tool for polishing language, especially for non-native English speakers trying to navigate complex grammatical rules or for brainstorming structural ideas. But you must never use it to generate core scientific content. And obviously, using it to fabricate data is a career-ending ethical violation.
Right. And transparency is paramount. If the journal requires it, you always declare your use of AI. But, beyond using AI to polish sentences, there's just the physical act of getting words on the page when you are chronically short on time.
Writer's block is real.
It is. The sources offer some brilliant productivity hacks to beat it. First, never start by writing the introduction.
Yeah, staring at a blank page trying to write the perfect opening hook is completely paralyzing.
Right. So instead, you start with the easiest parts. You write the methods section first, since it's just a recipe of what you already did. Or you build your figures and write the legends.
It lowers the barrier to entry. Once you have the methods and figures down, you have momentum on the page. Another critical habit is to write every single day, even if it is just for 30 minutes.
Just 30.
Yeah, the guidelines highly recommend the Pomodoro technique, working in focused, timed sprints, and fiercely protecting those writing blocks on your calendar. Do not let emails or lab meetings bleed into your writing time. Treat that 30-minute block with the same reverence you would a volatile chemical experiment.
I like that. So if we pull back and look at the bigger picture, why do all these habits and boundaries matter so much right now?
Because of where technology is heading. In a world where AI can easily draft a basic, grammatically perfect summary of data in 3 seconds, the mechanical act of writing is no longer the bottleneck in science.
Wow, yeah.
The true competitive advantage belongs strictly to the researchers who can articulate the human story behind the data. Why does this research matter? What does it actually change in society? AI cannot replicate genuine societal impact, empathy, or human curiosity.
That's such a powerful point. AI can give you a perfectly formatted summary, but it can't tell you why we should care.
Only you can do that.
So let's quickly synthesize what we've unpacked today. Scientific writing is a muscle. It's a trainable skill, not an innate gift. From stripping out the squid ink and using a precise 15-word title to crafting a clear narrative arc that passes the tweet test.
Yep.
We've talked about ensuring transparent data visualization with solid statistical pillars and building the psychological understanding of the peer review system to survive those brutal rejection rates. These are the tangible tools that ensure great science actually escapes the lab and reaches the world.
Exactly. It's about ensuring your data doesn't just sit on a hard drive, but actually contributes to the global conversation.
Before we wrap up today's deep dive, I want to leave you, the learner, with a final thought to mull over, building on that first and last rule we discussed earlier. If the psychology says the strongest ideas belong at the start and the end of a sequence, consider the entire life cycle of a scientific idea.
Okay.
The first is that raw, exciting Michelin star data you collected, and the last is the polished, stellar publication that makes it into a high-impact journal.
But what about the messy middle?
Exactly. The failed drafts, the confusing figures, the 90% of papers that get desk rejections. Right now, all of that just disappears.
Yeah.
Could there be a future where the scientific community values and actually publishes the messy middle?
That would be revolutionary.
What if those desk rejections and failed methodologies were shared just as widely as the final success stories to help other researchers avoid falling into the exact same pitfalls? Just something to ponder the next time you are staring down a blank page, trying to figure out how to plate your own Michelin star meal.